Hello everyone and welcome back. So let's take a look and see how we can create this and learn a few new things. So what we have here, we have circles copied a few times along a circle, and then they're linked together like this. So let's try and do that. Okay, I created a circle that has the points that I need, and then a smaller circle. I'm gonna simply copy them. Copy to points, cool. And we saw that the order of the point is important when we copy these circles, especially if we wanted to carve them. So let's do a carve. If we wanted to carve them, you can see that it's very important to have them properly aligned so that when we carve them, they all behave in the same way. Right now you can see they're all facing this angle, and we don't want that. We want them all to be facing a specific angle. So I'm going to copy the normal, this expression here, plugging P into N, plugging N into P. And let's use that. I'm going to change this to ZX, and now our points are aligned. Cool. So I don't need that part. I need this section. And now we need to loft connect all of them. And the easiest way to do that is using a fillet node. Let's create a fillet, and let's connect. Let's do that, and tick on wrap last. And you can see it's automatically figuring out all the details of what needs to be connected to what. You can see this edge is not flat, is not straight, so we need to adjust this to work better. Cool. We can also change this to convex and circular, and that gives us more detail, different silhouette. But I want something more interesting here, and the way we can do that is using, instead of using polygons, we can use NURBS curves, and we can convert any primitives we have into NURBS using a convert node. Here I'm going to change the convert to into NURBS curve. Okay, now if we use the fillet, it's going to behave differently because it's a NURBS curve, so the interpolation is different, and we can change it to convex, freeform, or circular. And what I want to do is, I like this. Let me check something. So I like this this shape here, and I want to be able to control, to be able to blend between this and this. So I can copy this, change this to circular, and I'm going to create a blend shape. And this I can do this now, and let's see, I can increase the number. I know this is weird, but if you increase the blend, it's going to give you a different geometry. You can also go all the way in, and that creates a different geometry as well. Okay, let's continue. I'm gonna fuse this just to make sure everything is good, and I'm gonna convert this into a polygon, back into a polygon, and let's extrude this. Let's do an extrude, and let's go use the global, and let's move the extrude up. Pardon me. And now we have interesting geometry extruded. Now the cool thing, we can do, let's see, we can rotate, and that will start introducing a twist into the geometry. And if we add divisions here, we can start doing more interesting twists. I'm very surprised. Let me check something super quick. Yeah, in my previous example, it's not creating that. It's not going to 0 for some reason. Let me check. Well, we can add the twist anyway, using just small rotation. That's how much I had before already, and we don't have to go all the way in to start seeing the volume loss. Now the great thing, we have this control, and we can change the shape of the pillar quickly. And this is basically the shape that we wanted, and then we have all this control to do other geometries, something like that. And what I want to show you guys is I want to add block separation into this. Remember the previous example that I did, we had these edges, that separation. I want to introduce it to any geometry we can have. But first let me resample this so it's it has less points. Cool. And I want to add separation along these lines. Okay, and maybe let's reduce them, something like that, and let's make these into blocks. So how can we do this? Well, let's try it. Let's do a group node, create a group node, and change it to edges. Turn off this, and let's play with the edge include by edges control. And here I'm going to tick on enable by angle and min and max. I'm going to tick both of them, and let's play with these guys. Nice. So at one point there we're going to be able to isolate these guys based on the edge length. And you see these guys are very long, these guys are very short, and that's what we're using. We're telling it to use to select any primitive that is between 0 and 0.6. But the problem is it's selecting these guys. Now it's not really a problem, but I want to show you guys how to fix it. I don't want them to include this because I'm only interested in the internals faces. So I'm going to create another group, and let me call this separation. Sep. And let's type in the same thing here, and I'm going to turn on group by edges again and turn on unshared edges, and let's change this to edges. Okay, now we're selecting only those two. We're going to reuse the same option here, intersect with existing. I'm going to change it to subtract from existing, and boom, we're selecting only those. Now what we need is we need to cut the geometry along those guys, and the node to use for that is edge cusp. Now look here, we have 141,430, and we're gonna tell the edge cusp to use that group sep. It needs a group with edges. Sorry, the 1500 points, and here it's 2800. So if we double click now, we can see the blocks are separated. Great. Now comes to the next important topic, which is the for each loop. Now what I need to do is let me remove this, okay, and delete this guy. What I want to do is I want to select this and do a fill and fill the fill it with polygon. So let's use a fill node, polyfill, and this is a great new node in Houdini 16 and 16.5, and look at that topology that it creates. It's just amazing how it analyzes the geometry and the result it produces. I really like this node, the new algorithm. There's few options, and in this case the grid is working. We can use other method later if we needed to. So let's put down a poly bevel, and here I'm gonna turn on flat edges, flat angle, and I'm gonna slide it all the way so that it only selects the parts that I'm interested in. If it doesn't do that, I'm gonna probably do it by hand, select them by hand. So let's set this to 0.2, too much, 0.5. Okay, let's increase this, change this to rounded, and we have the geometry that we need. Now the only problem is we cannot do it on the entire geometry. We have to operate on each block by itself. Well, what if we can create a unique attribute per block? Let's say we tell Houdini that this is number 1, this is number 2, this is number 3, this is number 4, 5, and so on and so forth. And then we tell it to use that information and operate on each block by itself, not an entire. We don't want to treat it all at once. We want to run the operation one block at a time. So Houdini has a node for that to generate this attribute that tells us this is 1, 2, 3, and that they are a unique entities, separated entities. The node for that is called connectivity node. So let me connect it, and let's move this aside. I don't need them. And if we take a look, it's creating an attribute called class, and let's call this parts or blocks. Okay, first block, second block. And let's take a look at the attribute. Now, see here it's 0, 0, 0, 0, and then it changes. Okay, let's use a color node and generate a random color based on this value, so we can see it, that it's unique for each of these guys. I'm going to change this to a random from value, and I'm going to use the blocks attribute, and voila, they are separated based on that. So we have a node in Houdini called for each that can read any input geometry and respect a given attribute to loop over the data. So it's going to do what we talked about, to go over each group of polygons or primitives that have one unique value, or a group or something that connects them together. And I'm going to create a for each, and I'm going to use a for each connected piece. And what this does, it comes in with the connectivity because it knows already that it wants to analyze the geometry and use its connectivity. Now it's set to primitive, and that's what we need. Here we have it set to points. We can swap this to primitive and use it. So, but instead I'm going to use this, and that generates the attribute that this section will know how to use. So if we take a look here, we're going to see one block at a time, which is this. If we take a look at this guy, it's going to show us the result of all of them. So let's add a transform and change the value. You see it's being applied to all of them at the same time. But we saw that we can use that $CX expression. Okay? Sorry. So let's do that. And what it's going to do is going to use the local pivot relative to each block. So this guy will have a pivot here. This guy will have a pivot in its center. And we'll see that the result is different. You can see it already, that it's different. Okay? Each one is being scaled based on its own axis. We can also rotate them based on that origin, and we can do this. You can see they're all rotating relative to their axis, and the reason for that is because this is looping over and each time operating on that specific context. Okay, now what we want is we want to do this stuff, we want to do the polyfill and the bevel. And once you plug in a node, it will get underneath this orange area will overlap it. That means it's part of the for each loop, and now it's doing this for the block. And if we run it for all of them, boom, we can change it, obviously. So let's reduce the amount, maybe 3, and now we have separate blocks, and we can go back all the way here, and let's change this to 1 and control that shape that we wanted. We can also do change the circles, obviously. Let's change this to 0.25, something like that. We can increase the count here. So let's change the size. Okay, this is very interesting already. Let's go to that bevel and play with the values a bit more. Cool. As you can see, everything is procedural at this point. Let's increase the 0.6, 5, and again it's running through the entire system. Let's try this. Let's do a grid. Let's try a box. Sorry, no, I want it to be 2 by 2. And let's resample its edges so it has more details on more points on these sides. How much did we have here? 38. Resample, set this to 38. Cool. So we have points. Let's see if that works. Scale the box down. It's working. The polyfill is failing in this case because of the geometry shape. So maybe we can change this to triangle fan or triangle to fill in all the geometry and see how that looks. But again, we changed something extreme in this case. Let's increase the point count. Let's increase the size of the box. It's still working. Yeah, there is some issues, but it's still doing what it's supposed to do. Here it's actually working pretty well. Let's take a look at the fill. Yeah, this is where things are getting a little bit messed up. So we have to probably tweak in this part because the point count, the point number is not the same as before. So maybe something like this would work better. Maybe. Not so sure what's happening. Yeah, I think I messed up something. But anyway, you guys get the idea from this example, and hopefully you can create some more complex geometry. Thank you guys for watching, and see you in a bit.